Good day guys, how you doing today? Today we continue from our previous lectures where we started with the introduction with Arduino programming. In this second lecture, I'm going to solve one of the examples in the slide you made use of in the previous lecture. We failed to consider this lecture in order to consider the time to finish this problem. Then we're going to consider this problem, this SOS beginning problems, one of the introduction to Arduino problems, to electronics problem, to beginner Arduino problems, and this is SOS beginning. SOS means just simple, can be in form of any SOS is used in search and rescue, in communication signals, in satellite communication, also known as international distress problem in Morse code. So we're going to look at how this works. The first short S tells us that you have short durations. The second zero tells us a little bit longer duration, and the second has also the same duration with this first duration here. But now let's try to look at the sample code and how it works, and let's also implement it either with the same code or with a different ideology of the code. And let's see. But let's use pin 30 for example here. So we configure our pin. Our pin is GPIO before, so we decide to use, you can use any of the pins since they are GPIOs, general purpose input output. So let's demonstrate with the use of LED. Now let's look at the functions here. Let's first create what function for a Morse code. That is the dot signal here. Then we create the dot. The dot means for we have the dot and the dashes. We use in our normal baking code, we use the dot and the dashes. Now let's see the dot code. Let's turn on LED for 150 milliseconds. 150 milliseconds, and then we also turn it off in the next 100 milliseconds. Then we also have the second dash, which represents the second signal here, that is 0. That is whole. Then at the rate of 450 milliseconds, then we turn it off. So we're going to see the behavior of the beacon code, or the SOS beacon behavior using these electronic communications, especially satellite communications. So we're going to see the behavior after we test this code and run it. Then when we create the functions to carry out the operation, for the first S, we have dot. The dot operates in what? In the input. It operates. Remember, we have this 3 milliseconds. It's telling us that we should pause the distance at which it pauses from X to 0. Then we also have dash, or the 0, which is the dash. This one stay long for longer time, but the first stay long for 50 milliseconds. Then after, it will not delay for 3 milliseconds. Then we later repeat the remaining 0. We use function for modularization here. For modularization, we have to module the code. In case you're having issue with the use of functions, we're also going to make use of, maybe let's just make use of simple for loop to loop through this code as well. Now let's demonstrate these problems let's demonstrate the problem. So before we start these problems, let's look at what is slide in the remaining slide. Then we have talked about, we've covered the Arduino problems and everything. We meet in the next chapter, but now before we meet, let's demonstrate this code. Now, let's open our Arduino code, Arduino IDE, sorry, Arduino IDE. Now I'm opening my Arduino IDE. It's in my phone. Applications of Arduino. So I'm using the Linux application file. Now I have the Morse code here. Now let's start from beginning. So let's have, this is Arduino, right? You can save it with the location where you want to save it. Then let's configure int LED pin, the port at which we are connecting our LED pin to. So we're going to configure to be pin 13. You can also choose pin 10 or pin 11 or pin 12, anyone you want. Then we now create, let's set up the pin. setup. I'm beginning from the scratch so that nothing will look confusing to us. So I'm beginning from the scratch here. Or let's just make use of maybe pin 11. Let's just choose pin 11 to avoid. So see. So then pin mode, the mode at which the pin is being configured is LED pin. It should be output, because LED is going to give us, it's an output device. LED is an output device. So therefore, after configuring it, the second function is the loop functions that will continuously run until the end of the program. So this will give us infinite looping. Now let's configure, let's loop, let's use our for loop. Where are we starting? Let's create a variable to start for all from 0 and less than 3. In case you are having issue with, you can also use the second code in the slide, which I've presented, but let's just use another method to solve the problem. Digital write. Digital write means we want to write to the output, of the or to the output screen. Let's digital write. Control space give me the IntelliSense. Then digital write the LED pin, the out I also you can put 1 if you like, and with semicolon to terminate the statement. Then we delay is in milliseconds. You know, the last time I told us milliseconds, 1 milliseconds is 10 raised to power minus 3. So we have 450 milliseconds, or like 300 milliseconds. That is 300 milliseconds will be 0.3 seconds. So then let's have it. That is 200, for example. Our first S. So for our first S dash, let's have 200 milliseconds. Then with the digital write, then LED pin low. So it's going to turn it off in the next 0.2 milliseconds. After turning it off again, delay for 200 milliseconds. Again, after delaying, so we have configured the first. This will pop up the LED but short signal duration of 200 milliseconds 3 times. Then after that, we can delay for 1000 milliseconds so that we can see the difference so that we can understand the difference. Let's first delay. That is 1 second. Now delay for 1 second. This delay for 1 second. Here, this one delay for 0.2 milliseconds or seconds, 0.2 seconds. So the same thing applicable here as well. So you can do that to avoid wasting time. So then we now loop again. Int I 0I minus. Remember, the reason why we're using, we start here, we start from 0, 0, 1. If we start from 0, first iteration, 0, we loop all this. The second iteration will be 1. It will loop throughout again. The third iteration will be 3. It's less than 3. You're not going to get to 3. If you are new to C, you can also check our playlist. Check my playlist. Also have the full details of C programming and even C++ programming. Then let's increase this now. Then we have digital write, LED pin I, delay. Now this one's going to take a longer time compared to the rest. Let's make it 500 milliseconds. Then digital write, LED pin low. We turn it off again, but the duration at which our SOS is going to work, this will take the same duration with this. So now we have delay 200 milliseconds. Then we delay again, delay 1000 milliseconds. We have the same code with this. The third one, we take the same code. Let's just copy this to fast track our time. Copy this and paste it. Then we can now delay maybe for like 4,000 milliseconds for inside. Why do we have to have 4,000 milliseconds? So that we can know the distance. We delay for 4 seconds. That will be 4,000 over 100. That will be 4,000 divided by 1,000, which is equal to 4 seconds. So get 4 seconds here. Delay for 4 seconds. Now let me explain the code again before we compile and run the problems. This is it here. We first configure the pin to what? To be set. The LED will be connected to pin 11. We set up the pin mode, the mode at which the pin will operate, either input or output. But here we are connecting LED. LED is an output device, so we connect to the output device. Then we now loop. This loop continues to loop. It's like a while loop, which will continue to loop forever. Then for our first X, remember for our first X, what's our slide? Now first X here, you can see the dot for short duration of signals. Our first X, our second X, our 0, SOS, and short S. You can see from the slide. Now, let's continue. This will be for the first S. The first S. And delay. The other one also for what? For O. And the other one also for X. So we also delay. Now let's see the signal, SOS signal. I also want you to practice this code so that you can also understand it. After compiling this code, then we can now turn on our, please open your, let me open my, the PICSimLab. For instance, let's open the PICSimLab. The PICSimLab is open now. So this is the demonstration of the first signal. But let's load. This is on pin 13. Let's use any of these LED here. Let's select this one. Let's choose pin 11. Pin 11. Remember, the 11 here is the 11 now. Pin 11. Then we click OK. Then we load our file. We load the S file, our firmware. Let's load the firmware. It's in TD is good. I think I'm discovering one error there. Now you can see that we're not seeing anything. Let's export our file. We don't export it. After finish the code, after finish compiling, please ensure you export. Come to the files or your sketch, export this compiled binary code to your folder directory, or else it's going to be in your temporary file. Export. Then let's come back to our simulation design. Let's load it again. All. And you see, it's loading now. It's loading the code, but it's not good. It's not turning on. Let's see this property pin 11 here. This is working on pin 11 because this is on pin 11. But let's make use of the second one. Let's tell this one to be no connections, so that we'll be sure. Let's make use of the second LED. Let's say to pin 11. Should start automatically. Okay, it's picking the first one as pin 11. Now let me pick us is as pin 11. So this, can you see this pin 11 showing here already? So you can also change the color in case you want. Now you can also design this circuit yourself by opening our SimulIDE. I've also shown us I'll just search for Arduino. This SimulIDE. Let's search for Arduino from our components. Arduino. Or let's search for Uno. This is an Uno. You can search for it here. I'll also zoom in later. Then the LED. And then search for resistor. And then let's also search for the ground. Yeah. Let me fit to this. Now I can zoom in. Now this is the Arduino Uno here. We make use of pin 11, right? This is my LED. Let me reverse it to this is my anode side. Let's go to pin 11. This is my resistor. It is good for you to attach your resistor to it if you are doing it in a live mode. So then let's load the firmware here. Right click and let's make it full so you can see very well. So can you see? Let's load the firmware. Right click and let's load firmware. The firmware is inside the projects, and then the X file, the one with the X file, we're going to copy. Then let's compile the scene. You see? The same thing is working the same way. Alright, thank you very much. Please like, subscribe, have a wonderful day. Bye bye. Please leave all the comments below in the comment below section. Any complaint on extension or any further observation you think is more better than this, please let me know in the comment section. Thank you very much. Bye bye.